is fire protection, which includes, of course, safe means of exit or egress, fire detection and alarm system or FDAS, toxic gas detection and extraction, and stairwell pressurization, and extinguishing agents, and a discussion on automatic fire sprinkler system. So I'm Engineer William J. Juan, a professional electrical engineer, a registered master plumber, an MEPF practitioner, as well as a solar energy advocate. So let's proceed with our invocation. Amang banal, pinupuri ka namin at pinasasalamatan sa mga biyaya at sa tuloy-tuloy mong paggabay sa amin. Maraming salamat po sa pagkakataon na makapaglingkod sa aming mga kapatid at sa aming bayan. Sana po magawain ito ay magbibigay ng dagdag na kalaman, kakayahan at kaunlaran ng bawat isa at para sa aming bayan. At sana po ilayo mo po kami sa sakit at saka sakuna. Lahat pong ito ay aming tinataas sa iyo, dakilang Ama, sa pangalan ng iyong anak na si Jesus. Amen. Okay, so let's look at our table of contents. So here we have rearranged this from its original sequence, no? Of course, we will be discussing again the backgrounders or introduction, and then number 2 will be this topic on safe means of egress or fire exits. So what to see when to ensure that our means of egress are safe. Then number 3A is fire detection and alarm system. Number 3B is toxic gas detection and extraction. This is our baby, toxic gas detection, including carbon monoxide detection. And 3C is smoke extractions. And 3D is air pressurization of stairwells. And 4 are fire extinguishing agents. And 5 is a discussion on wet sprinkler system or requirements of sprinkler design. Okay, so let's start immediately our introduction. So again, let me emphasize that fire protection, including FDAS, should be mandatory, no? Yes, in order to save lives, in order to save properties. And again, our data from the Bureau of Fire Protection shows that the Philippines had 17,000 fire incidents in 2015. Causing more than 3 billion worth of damages on properties. And additional data shows from the Bureau of Fire shows that 70% of fire incidents at that year occurred in homes.
In 2024, the Bureau of Fire Protection reported an 11.2% rise in fire incidents, with a total of 18,217 cases and property damage of almost 14 billion pesos. 1A.3. The Filipino home needs a fire alarm system. A recent market survey conducted shows that 84% of Filipinos consider fire as the second top threat to physical safety, next to earthquakes at 91%. Other potential physical threats include building collapses, 69%, terrorism, 64%, and floods, 33%. 1A.5. The Filipino home needs a fire alarm system. Survey shows that only 17% of Filipino homes have fire alarm systems, compared to 97% of commercial buildings. While commercial buildings have fire exits, smoke detectors, sprinklers, and CCTVs, residential houses do not follow the same standards and protocols. 1A.6. Let U.S. ponder on this situation. There are no smoke detectors or fire sprinklers inside your room or home. You were too tired from work, had a good night out with friends and had a drink too many, went home, went to bed, and fell into a deep sleep. Then, unfortunately, An accident happened. A fire broke out inside your room or in your home. If nobody wakes you up, you are facing imminent death due to suffocation from smoke.
What is our suggestion to this? Okay, our suggestion is for the 2008 Fire Code to be upgraded, no? Maybe the IRR, the implementing rule, may be upgraded to make mandatory the installation of smoke detectors in every home, because as per our findings, only in the commercial buildings are the FDAS or smoke detectors are being implemented more strictly, showing about 97% of commercial buildings has these smoke detectors, and only 17% of the homes have this. So that's the big danger. If there is a fire that may happen in the homes, then maybe many people might perish. Okay, number 2 suggestion from yours truly is to make mandatory the installation of detectors of toxic gases, no? Toxic gas detectors. That means I'm pointing at carbon monoxide and hydrogen sulfide. These are the gases, toxic gases that may be present in the homes or inside buildings, no? And these toxic gas detectors should cause an alarm to wake up the people inside the building or to alarm them. And extraction fan, exhaust fan or extraction fan must also be installed to ensure that these toxic gases will not stay in the room during a fire, but they should be sucked out of the enclosure of the air-conditioned space in the building. So let's repeat. Number 1 suggestion is to make mandatory the provision of FDAS, fire detection and alarm system, in every home, not only in office or commercial buildings. And number 2, to make mandatory the installation of toxic gas detectors, alarms, and extraction system. So these are not yet in there. It's not also in the NFPA yet. This number 2. Only number 1 is in the NFPA, except that in the IRR, it is not very strict when it comes to every home. Okay? So, let us analyze our present design of the fire detection and alarm system. To cause an alarm and awaken a human being, the following human senses respond. No, number 1 is the sense of smell. So, if there is a fire and you are inside the burning room, then chances are you will be able to smell the smell of the fire. So that means it could alarm you, or it could alarm the person that is inside a burning room or building. Okay, of course, this is in the assumption that the person has no problem with his sense of smell. Okay, number 2 is the sense of hearing. So today, the sense of hearing, we have the audio-visual alarm included in the fire detection and alarm system. So therefore, the sense of hearing is actuated or is utilized. Okay. And number 3 is the sense of seeing. Like I said, these 2 are in the present design, audio-visual. How about sense of feeling? The sense of feeling is not yet there, but we have suggested already, and that is by the use of smart watches, mga relos, no, that has the capacity to vibrate. The watch, the smart watch, must have a SIM card inside, so that in case of a fire, the programmable logic control or the fire alarm control panel, which is a computer, will send a signal to the SIM card of your smartwatch, and the smartwatch will vibrate, and therefore it will affect this sense of feeling for an individual, for him to be awakened. So therefore, as of today, inside the burning room, you have the sense of smell, then the sense of hearing is part of the FDAS today, and the sense of seeing is also part of the FDAS because of the alarm light, the rotating beacon, and the LED lamp. And the sense of feeling can already be included, but of course only in the in the addressable type. In the conventional, it is not yet possible in there because unless they can modify it, that when a conventional fire alarm control panel is being actuated, it can also send a signal to a SIM card. So it is also possible, but as of today, it is a little harder for it to be realized. No? Now, the sense of taste is not possible as of this time. How would you affect a person to receive to respond to to stimuli and this sense of taste from a fire? So there's no technology yet on this, only the present sense of hearing, sense of seeing, and a possible sense of feeling. Like I said, sense of smell is only through the inside the burning room. Those who are not inside the burning room will not be able to have this. So maybe later on when the fire is already very big. So now here let's analyze two slides which would explain the sequence of operation of a fire. So I mentioned this first slide as the life-saving process. So a smoke, fire detection, alarm, evacuation, life-saving process. So when a fire breaks, then it will develop smoke, or smoke develops, and smoke will be received by smoke detectors, and the detectors will actuate the fire alarm control panels. No? Or if extraordinary heat is detected by heat detectors, they will also send signal to your fire alarm control panel, and your FACP will send you a signal to your audiovisual alarm. And of course, this include ringer, buzzer, hotter, rotating beacon, and so on. And like I said, you can also include the smartwatch vibrator that I was mentioning earlier. And you can now actuate your stairwell pressurization so that the escape routes are pressurized. Okay, and then smoke extraction can also happen, so that therefore safe evacuation of people or humans from a building would become possible. The next slide is fire suppression. So after the life-saving process, now we have this fire suppression and life property saving process. So again, as usual, in a building that has an automatic fire sprinkler system, okay, your jockey pump is always running every now and then in order to pressurize the hydraulic system, meaning to say the sprinkler system of the building. So the jockey pump runs, and then when suddenly there is a fire, then the fire becomes big, builds up, and hits up a sprinkler that is just above the fire. The sprinkler will then operate because it works like a bimetallic nozzle, spray nozzle. So it hits up the sprinkler nozzle. The nozzle will start to sprinkler water, and then immediately when the water sprinklers, the pressure of water inside the hydraulic system, the sprinkler system, will drop rapidly. It will drop rapidly, and a sensor at the header near the fire pump will actuate the fire pump to start. No? So automatically the fire pump will start, and therefore the fire pump will deliver the fire water. At the initial point, the sprinkler nearest to the fire will just be the initiator. No? It will be the initiator. The moment it sprinklers, pressure drops, then the sensor in the system will determine this, so automatically will run the fire pump, and then of course the fire pump will continuously supply the fire water. Even if there will be more sprinklers that will operate, fire pump should be able to deliver the fire water. Okay, until of course fire trucks arrive. Your firemen will help put up the fire. Okay, so the fire pump still operates even if the firemen arrive. Not until they would be able to contain the fire, and therefore that's the time they will, of course, stop maybe the fire pump. Okay, if the fire is already under control, and of course the firemen will connect their hoses to the Siamese twin or the fire department connection in front of the building. Okay, so that's how it is. No, the first slide is detection of a fire through a smoke, and then the actuation of the control panel to initiate an alarm, so that people, when they are alarmed, will run from the building to go out to save themselves. While in the second slide is this is for the fire pump or the sprinkler system to operate. Okay, so therefore the first slide is more of saving the people, the occupants of the building, while the second slide is more of saving the property, because the sprinklers, the water in the sprinklers cannot save a person, because if a person is still inside the building, and still there, chances are he will get suffocated, or he will be inhaling the toxic gas like the carbon monoxide and some others, and that will kill him. So therefore, it is therefore the fire detection and alarm system that is life-saving. And this sprinkler system is more of property saving, no? To prevent the fire from spreading, and of course from weakening the building. If the building is reinforced concrete, the thickness of the concrete that envelopes the reinforcing bars is only good for a certain number of hours. Okay, otherwise, when the fire continues, then it will weaken the concrete and eventually weaken the entire building. This is much more when you have steel. You have a building that is constructed of steel, and there is no provision of protecting the steel. Then when there is fire, your steel will become weak, become softened, no, by the heat of the fire. Do you remember the World Trade Center fire or accident in when was that, 2001, I think, 911, 911, September 11, was it? Anyway, so as you would see, the building, after it caught fire, weakened, and then it collapsed. So with the second building in the World Trade Center. Okay, so fire consists of can be created if you have air, which contain oxygen, and you have a fuel, and of course you have a heat or spark. So these are the three composition of fire. So if you don't have air, then you don't have fire. If you don't have heat or spark, you don't have fire. If you don't have fuel, then you don't have fire. So therefore, knowing these three, you could be able to formulate how you could probably prevent a fire. Okay, I just want to show you that this is a wrong installation, where in a gasoline station, the owner and the contractor and the designer allowed the installation of a panel board with circuit breakers very close to a gas dispensing unit. This is a violation of the code. No, you do not install breakers that are very close to sources of flammable substances like this dispensing unit of a gasoline station. No way. This is not possible. You know, this is a small player. I did not take any picture already of the name of this small player. If you take note of the gasoline stations of Shell, Caltex, and Petron, and even Total, they are made of higher level of safety or engineering or quality. No, not this small player. This is somewhere there in Taguig, along the East Service Road. I hope it is already corrected by the owner or the local building official of Taguig City. Okay, and it is a double whammy because again, this another picture showing it. If you see, if the panel board is here above, you would see an outlet here below, and therefore it is much even closer to the gas dispenser, no? Okay, so it's a violation of the code, really. The engineer who signed the plans do not know his code. The one to supervise the project also doesn't know the code, and much more the building official, the inspector who allowed this to be done. So anyway, so let's make it as a lesson. Should not happen. Should not be done again in other parts of the country. Okay, so fire can be spread through convection, radiation, and conduction. And here is a more a clearer illustration of the three. Convection, so that's the direct, and radiation. Okay, so the rang, no? And conduction is can be transmitted by material, no? So therefore, this conduction is very important in order to prevent the spread of fire by having firewalls, no? Rated firewalls. Okay, so here are three ordinary combustibles. We have type A fire are caused by fuels like paper, cloth, wood, rubber, plastics, and they would require water to extinguish it. So it's they are labeled type A. And type B are those that are flammable substances, including oil, gasoline, some paints like lacquer paints or paint thinner, grease, solvents, kerosene, LPG, and even natural gases like methane and so on. No? And letter C is electrical equipment fire. So when you have arc flash, when you have electricity that would jump from one line to the other, like a short circuit, then that is class C fire. And class C fire, you do not use water. Okay, for both type B and type C, you use extinguishing agents, like for example nitrogen can be used there, no? Argonite is also possible, and of course some special materials like FM200, Novec, Energen, and some other inert gases. Okay, so now we go to part 2. Safe means of egress. So that means what is safe means of egress, or safe means of exit, or safe fire exits? That's what it means. Okay, so you must have when you have this kind of a building very high, so you would see it's really very, very difficult to control the fire. So people must be provided with a safe means of egress, no? So you can imagine this kind of building get burning. You would think of probably using parachutes to save people. Can you provide for parachutes, or can you provide for helicopters to pick up people at the top of the building, or what else? So many things, because mostly people will run to the stairs, and they would scamper for safety from wherever they are in the building. If the fire is in the middle and a person is in the uppermost floors, they would run the risk of being exposed to this smoke. And smoke is carbon dioxide, and there is also the carbon monoxide that I'm mentioning, which would kill persons, no? Especially those that have some history of sickness. Okay, so you have to provide this kind of fire escapes, no? Very important. Open fire escape is still the easiest way for means of egress in case of fire, no? So that's why the Bureau of Fire people will always require a fire exit, because the moment you already come out of your window and go to here, then you are already exposed to fresh air. So even if the smoke is coming to your way, at least it will not be as devastating when you are inside a stairwell. When you're inside an enclosed stairwell and the smoke is so bad, oh, very, very dangerous. So you have to check on this when you inspect the minimum width of doors, no, for exits. 1.2 meters should be the minimum width of fire exits, and they must be provided with exit signs very clearly, okay, so that people would know where to run for safety. And of course, there is the panic bar. The panic bar is when you push this bar here and the exit door will open. So this must be checked, test every now and then to make sure that the panic bars are working all right. And we should not allow putting this garbage or this storage or making the exit storage. No, it's not. It is against the law. This must be kept open all the time, because when there is an emergency, these storage boxes will just slow down the movement of people exiting. Okay, and of course, this one is another example of a violation. Should not allow this. Fire exit, do not block. It's there, but still people put basura, no, which is not good, no. Okay, and outside must all be checked. If the inside should be clear, and then outside should also be clear. No, we should not allow garbage to be put in the fire exits, which may hamper the opening of the fire exit door. So we have to check our facilities with this. And like this one also, you would see the owner just put tables, no. Maybe they do not have the space, but they should clear this exit area. And exit doors should not be padlocked, should never be padlocked. Otherwise, you are just like imprisoning the people inside. When there is an emergency, you will not be able to go to and get the key anymore and open this. So people may die. And never would you allow parking just fronting exit doors like in this picture, no? So if it is an exit door, it's better to put barriers there, barriers mounted so that cars and other will not park on it, no? So not just simply fire exit, do not park. You must put bollards or barriers in there so that they will not park in front of the fire exit door. And of course, you have to install signages. Fire exit, do not block, emergency exit only, do not block, fire exit, whichever, no? And they must be very visible and installed plenty. Okay, so it should be analyzed where these signages must be located so that people inside the building would have a guide on where they will go to exit the building.